Hello, today we are going to learn about parallel combination of resistor. So when resistors are connected side by side, we call this parallel connection. As you can see, both resistors are connected at the same points. One end of each resistor is joined together using this wire, and the other ends are also connected using another wire. And from this, let us define parallel combination of resistors. So parallel combination of resistors is when two or more resistors are connected side by side, and because of this arrangement, the current has more than one path to flow through. So as we can see, there are two paths in these two resistors, right? And the current can flow in this direction, and or it can also flow in this this other direction. Okay, let us measure the current and the voltage. To know the values of current and voltage, we have to connect a voltage source, right? So let us connect 9-volt battery to this circuit, and when we measure the voltage across the battery, we get what? We get 9 volts. And when we measure the voltage across the resistor R1, which is the upper resistor, we again get 9 volts. And simply, when we measure also, when we measure the voltage across resistor 2, which is the lower resistor, we again get 9 volts. So what does this shows is what, in parallel combination of resistors, what the voltage across each resistor is the same. Now let us measure the current. Before we measuring, we need to what, we need to know the resistance value of each resistor. So let us assume a resistance of the first resistor is 50 ohms, and resistance of the second resistor is also 50 ohms. And when we measure the current at the battery terminals, we get 0.363 0.36 amperes, right? And when we measure the current through the first resistor, we get 0.18 amperes. And also when we measure the current through the second resistor, we also get 0.18 amperes. So from this, the behavior of current is what, in in parallel in parallel, the total current is the sum of the currents flowing through each resistor. This is what we get current of R1, which is 0.18 amperes, and for R2 we get 0.18 amperes, right? So this means the total current is equal to what? Equals 0.18 amperes plus what? Plus 0.18 amperes. Then which gives us what? Gives us 0.36 amperes. So the total current is what? 0.36 amperes, which is the summation of the sum of two resistances in a two resistor is what? Is equal to the total current. Our total current is what? 0.36 amperes. And finally, so and so this shows what? Shows that what? In a parallel combination of resistors, as we see, the current is what? Current is divided among resistors. And as we saw in previous, which is in series combination of resistors, what is divided is what? What is divided is voltage is divided. So in parallel combination, current is divided. In series combination, voltage is divided. And finally, let us measure the total resistance of the circuit. When we measure, we get what? We get 25 ohms, right? So which is this is what? Which is less than the individual resistances. This means that in a parallel combination from this, in parallel combination, the equivalent or total resistance is what? Is less than the individual resistances. This means the resistance of first resistance, the resistance of what? The resistance of first resistor and the resistance of second resistor is what? Greater than, which is total or equivalent resistance, which is equivalent resistance or total resistance is less than these two resistors, resistance of these two resistors. And in our case, what? In our case, we get what? We get, which is for 50 ohms of two resistors. In our case, the equivalent resistance is equals what? Equals 25 ohms, which is less than 50 ohms. So we can write these expressions mathematically as what? As V is what? From battery or from voltage source. V is equal to V1 is equal to V2 is equal to V3 is equal to so on. And I total, which is from the battery, is equal to summation of individual resistances current, which is I total is equal to I1 plus I2 plus I3 plus so on. And which is total resistance or equivalent resistance is mathematically expressed as 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus so on. So from this, in parallel, always what? Always total resistance is less than what? Less than two resistors, which is less than, if we have here as example we have two resistors, but if there is three or more resistors less than that resistor, so this means mathematically R total, which is R equivalent, is less than R1, R2, R3, and so on. And let us look at this circuit and also this circuit. Both these circuits are in what? In parallel combination, and these circuits are what? Parallel combination circuits. Because what? Because of what? Because of these circuits. This circuit with let's see this circuit with two resistors. In this circuit with two resistors, the current flows from the voltage source, and current flow can flow through what? Through R1, and current can also flow through R2. And also let us see in the circuit with three resistors, current can flows from current flows from what? From, as we know, from the voltage source, and uh, it can flow through what? Through resistor 1, and can also can flow through resistor 2, and also current can flow through resistor 3. So as we can see, there is what? There is an alternative path for current. So when there is an alternative current path, the circuit is what? The circuit is what? Is parallel combination circuit. So these two circuits are parallel combination circuits. So as we know, 1 over equivalent or total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus so on, right? So the question is, so let us derive this formula where it comes from. To derive, let us use simple circuit with three resistors in parallel, and as we know, in parallel, V or V total is equal to V1 is equal to V3 is equal to Vn, which is so on. And as we know, I is split or divided into each resistor. So this means what? For resistor 1, I1 is equal to V over R1, right? And for resistor 2, I2 is equal to V over R2. And for resistor 3, I3 is equal to V over R3. And we know that for all resistors, I total is equal to I1 plus I2 plus I3. So we put the above equations for in this equation. So above equation into this equation. So for I1, we put this equation into I1, and for I2 we put this equation into I2, and for I3 we put this equation into I3. And so after we substitute, we get what? We get I total is equal to V, or voltage, over what? Over R1 plus, for I2 we substitute V over R2. So V over R2 plus, for I3 we have V over R3, right? We substitute this, so V over R3. Then, so we have common V, so we take it outside, then we get what? I total is equal to V times what? Times 1 over R1 plus 1 over R2 plus 1 over R3. And after we finish this, we know from Ohm's law, I total is equal to what? Equal to V over R equivalent, and which is I total is equal to, we substitute the above equation, we get, which is V times 1 over R1 plus 1 over R2 plus 1 over R3. Then what? Then we divide by V on both sides. So then then after we divide on the right side, V is cancelled out by V, and also on the left side, V is cancelled out by V, and we are left with what? Left with 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So from this, we can say our general formula is what? Our general formula is 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and so on. And using summation, 1 over R equivalent is equal to the sum from I equal to 1 to n of 1 over Ri. And in a special case for two resistors in parallel, we can use what? You can use R equivalent is equal to R1 times R2 divided by the summation of R1 plus R2.